Hello everyone, today we are going to analyze this frame using moment distribution method. The support D settles by 6 upon EI downwards. In the column AB, there is a point load 25 kN which acts at a distance of 3 meter from the fixed end A. There is a couple 20 kN. It is acting in the clockwise direction and it acts in the node C. Length of column AB is 5 meter. Length of beam BC is 5 meter and length of the column CD is 2 meter. Let us find the fixed end moments in the column AB. If there is an eccentric point load, these are the two formulas we have done so many times in the previous problems. Here W is 25, A is 3 and B is 2. We can apply them so that we will get these. In the beam BC, there is no load, but the support D settles by 6 upon EI. So there will be movements due to sinking. They will be developed in the beam BC. If you take the beam BC, the sinking occurs on the right side. We know that if the sinking occurs on the right side, the sinking moments should be negative. In the formula, let us apply the values. Here L is 5, so it is 5 square, and delta is 6 upon EI. We can eliminate EI, thereby getting minus 1.44 kN for both of the fixed end moments. In the column CD, there is no load, so both of the fixed end moments will be 0. We know that this is a sway type frame. Also, we know that in the moment distribution method, we have to do the analysis 2 times. First, non-sway analysis. Let us assume that the sway occurs towards the right side. To prevent the sway, let us keep a horizontal support P in the point C towards the left side. First, let us find the stiffness. These two ends are fixed and these two are continuous. So all of the formulas will be 4EI upon L. For BA, BC and CB, L is 5 and for CD it is 2. Then we need to add these two and then these two so that we will get summation of stiffness. Then using this formula we can find the distribution factors. We can start making the table. In the table first we have to enter all of the members, then the distribution factors, then the fixed end moments. Let us start the first distribution in the joint B. For that we have to add these two and then multiply with the distribution factors. Both the distribution factors are same, so for both of them we will get the same value, and we know that if we get positive we have to write as negative. Now let us take the joint C. We have to add these two and then multiply with the distribution factors so that we will get these two values. In the joint C, there is a couple moment 20 kN. For this we have to make a different moment distribution table. But here I will introduce a shortcut. The couple is acting in the clockwise direction, so it should be taken as positive. Then we have to multiply with the distribution factors so that we will get these two. Now we have to add these two and these two, but here we have to be very careful. We know that in the moment distribution table, we have to write the distribution values as positive if they are negative and negative if they are positive. So these two values should be taken as positive, but the values after getting balancing the couple should be kept the same. We should not change the sign. If it is negative, that is negative. If it is positive, that is positive. Here we have to be very careful. So it will be 5.7143 plus 0.4114. We will get this value, and then 14.2857 plus 1.0286. We will get this value. Now we can do the carryover. We need to divide these values by 2 so that we will get the carryover values. Now let us do the second distribution. We have to multiply this value with a 0.5 so that we will get this. Since we have got positive values, we have to write them as negative. And then at C, we have to multiply this with these two distribution factors. Since we have got negative values, we have to write them as positive. Here you can see the carryover, and here the third distribution, then the carryover. You can do more distributions and carryovers until you are getting very smaller values. In the sixth distribution, you can see that I am getting very less values, so I am going to stop here. But you can see that in the fourth distribution itself, you are getting less values. Here also you can stop, it does not matter. We know that in the last distribution, we have to give the carryover to the fixed ends. After adding, we will get the final moments. Let us take the moments in AB and BA. In AB, it is in anti-clockwise direction because it is negative, and for BA, it is clockwise. Now let us take the column AB. Let us assume that HA is acting towards the left side. If we get a negative value, we can change the sign. Let us take moment about B. HA is acting in the clockwise direction, so positive, and the distance is 5. So 5 HA. This moment is acting in the anti-clockwise direction, so negative, and this is acting in the clockwise direction, so positive. This load is acting in the anti-clockwise direction, so it will be negative, and the distance is 2. For HA, we will get a positive value. That means our assumed direction is correct. Now let us take the moments in CD and DC. For both of them, we have got positive values. That means both of them are in the clockwise direction. By taking moment about C, let us find HD. Here we need to follow left hand side rule. HD is acting in the anti-clockwise direction, so positive, and the distance is 2. So 2 HD. Both of the moments are acting in the clockwise direction, so both of them are negative. For HD, we will get 14.21 kilonewton. Now let us take the frame and apply this rule. These two are acting towards the right side, both of them are positive. And these two are acting towards the left side, so both of them are negative. So for P, we will get 27.358 kilonewton. For P, we have got a positive value. That means our assumption is correct. Sway occurs towards the right side. The value of P preventing sway is towards the left side. So the sway force should be acting towards the right side. Now let us start the sway analysis. We know that the sway occurs towards the right side. So let the frame sway by delta towards the right side. From every column, we have to take any one moment. For BA, let us take the moment M of BA. And from CD, let us take M of CD. We know the formula for the moment developed due to sway. This is the one. But the sway occurs towards the right side. So the sway moment will be negative. For BA, the length is 5. And for CD, it is 2. We will get these two. For both of the moments in column AB, we need to keep minus 0.24. And for both of the moments in column CD, we have to keep minus 1.5. We have to keep the moments in BC as 0. This is the moment distribution table. In the previous problem, I have explained many times how to make this table. So I don't want to waste the time here. If you have any doubt, you can see the previous problems in the playlist. For the final moments, we will get these. Let us take these two moments. Both of them are negative. That means they are acting in the anti-clockwise direction. By taking moment about B, we can find HA. HA is acting in the clockwise direction, so positive, and the distance is 5. So 5 HA. Both of the moments are anti-clockwise, so both of them are negative. For HA, we will get this. For HA, we have got a positive value. That means our assumed direction is correct. Now let us take these two. Here also, both of them are negative. That means both of them are acting in the anti-clockwise direction. Let us take a moment about C and find HD. HD is acting in the clockwise direction, so negative, and the distance is 2. Both of these two moments are acting in the anti-clockwise direction, so both of them are positive as per the left hand side rule. For HD, we will get 0.701. We have got a positive value. That means our assumed direction is correct. Now let us apply this rule and find the sway force S dash. These two are acting towards the left side, so both of them are negative. This is acting towards the right side, so positive. For S dash, we will get 0.793 kilonewton, and it is acting towards the right side. Now let us find the correction factor. This is the formula S by S dash. We will get this. We can round this as 34.5. First we need to enter the sway moments. Then the sway moments into the correction factor 34.5. We will get this. Then we have to enter the non-sway moments. To get the correct final moments, we have to add these two so that we will get these. For MBA and MBC, we will get a very small value. We can round that to 0. Here you can see the bending moment diagram by superposition method. Let us take the column AB. By taking moment about B, we can find HA. And by applying this rule, we can find HB. Let us find the bending moment under the point load. This is acting in the anti-clockwise direction, so negative. This load is acting in the clockwise direction, so positive. And the distance is 3. Finally, we will get 19.95 kilonewton meter. Let us take the beam BC. By taking moment about C, we can find VB. In this beam, there is no vertical load, so VB and VC will be same, but only they will be in the opposite direction. VB is acting downwards, so VC should be acting upwards, but both of them will be 3.21. By taking moment about C, we can find HD. HD is acting towards the left side, so HC should be acting towards the right side, but both of them will be having the same value, 9.97. Here you can see the shear force diagram. Here you can see the bending moment diagram. If you draw the bending moment diagram in the opposite side, that is called bending moment diagram on the tension side. Here you can see the point of contraflexure. We can take this triangle and to find the distance. By applying the similar triangle rule, we can find the distance of X as 1.67 meter. So this distance is 1.67 meter. Now we are going to end this session. Thank you for watching this video.